Hello there, and welcome to Documentary for Sleep, where the world unfolds slowly, where time stretches softly around us, and where the stories of our planet are told not in a rush, but in the patient way the Earth itself seems to keep. Tonight, we're going to drift back into one of the longest, strangest, and most powerful chapters of our world's story. A chapter written not in stone or in bone, but in ice. We're going to talk about the Ice Ages, the great long winters that shaped continents, carved valleys, raised mountains of cold, and quietly redrew the face of the planet again and again. And though they may feel like distant, almost mythical events, you might be surprised to find that the world you live in, the very ground you stand on, the rivers, the lakes, the soils, the coastlines, even the cities, and the way we move across the land, all of it carries the fingerprint of the ice. Before we begin, I wonder where you're listening from right now. Is it night where you are, the world settled into stillness, the lamp dimmed, the air around you quiet? Or is it perhaps a morning, the light only just beginning to slip through the curtains, the day not yet fully arrived? Wherever you are, however you are, settle in. Let your shoulders ease, let your breathing slow. There's no hurry here. The Ice Ages took millions of years to unfold, and we have all the time we need to wander through them gently. If this slow journey is the kind of thing you enjoy, perhaps consider giving the video a like, or even subscribing if you'd like to be part of these quiet explorations. It helps other curious listeners find their way here, to this little corner of the night, where science isn't a race toward answers, but a slow looking around at the wonders we sometimes forget. And so, let us begin together, with the patience the Earth itself rewards, by trying to picture what an ice age really is. To imagine the world covered in ice is to imagine something both strange and oddly familiar. Strange because the scale is so vast, and familiar because we still live in the long shadow of the most recent one. You might think of the Ice Ages as something that happened once, long ago, and then ended, but that picture is not quite right. In truth, the Ice Ages were many, separated by enormous stretches of warmth, returning again and again across the history of the Earth, like a slow tide that comes and goes on a scale measured not in hours, but in millions of years. The cold has come and the cold has gone, and each time it has left its mark, sometimes a gentle one, sometimes a transformation so profound that the world that emerged afterward was scarcely recognizable. To understand this, we need to let go of our usual sense of time. We need to imagine an Earth not as we know it now, but as it has been, across hundreds of millions of years. Continents drifting in slow motion, oceans opening and closing, mountains rising and wearing away. And through it all, sometimes the planet itself growing colder, ice creeping outward from the poles, glaciers thickening, sea levels falling, and an entire world being reshaped by frozen water. So picture that for a moment. Picture the planet from far away, as if you were drifting in space, watching the surface change over millions of years. You would see green continents fade to white at their edges as ice spreads outward. You would see the oceans pulling back as water locked itself away in the great ice sheets, exposing land that had been hidden beneath the waves. You would see deserts shrink and grow, forests retreat to small refuges, grasslands stretch across the cold, dry plains. And then, slowly, you would see the ice retreating again, the green returning, the oceans rising, the world becoming warm and lush before the cold began to gather once more. This is the great breathing rhythm of the planet, and it is in this rhythm that the story of the Ice Ages lives. Tonight, we will walk through that rhythm together, gently and without hurry. We'll talk about what an ice age actually is, and you may be surprised to learn that we are technically still inside one. We'll travel back to the most ancient freezes, when the entire planet may have been wrapped in ice from pole to pole. We'll learn about the warm gaps between, when palms grew at the edges of the Arctic. We'll arrive at the great ice age of the recent past, the one that shaped the world our ancestors first walked into. We'll talk about the slow rhythms of the sky that drive the ice, the gravitational pulls and orbital wobbles that decide when the cold returns. We'll watch the ice itself, vast sheets thicker than mountains, and see how it sculpted the landscapes we now call home. We'll wade into the seas of the time, see the land bridges that emerged, see the great animals that lived in the cold, the mammoths and the saber-toothed cats, and the giant ground sloths. We'll follow the first humans across the ice, into new continents. We'll watch the thaw begin, the rivers flood, the new world emerge, and finally, we'll come back to the present and look at the world around us and see, perhaps for the first time, just how much of it was shaped by the ice. So take a slow breath, let yourself settle. There's nothing you need to do but listen. The ice has waited a long time to tell you its story, and the night, like the ice, is patient. The phrase Ice Age sounds simple, but it carries a meaning that surprises many people the first time they really sit with it. When most of us hear it, we picture a frozen world, white landscapes stretching to the horizon, mammoths plodding through the snow, ice covering everything from the poles to the temperate zones. And in some sense, that picture isn't wrong, but it captures only part of the truth. Because an ice age, in the way scientists actually use the term, is not just a single frozen moment. It's a long, long span of time during which the Earth holds permanent ice somewhere on its surface, especially at the poles. By that definition, an ice age can last for millions of years, even tens of millions, and within it, the cold itself comes and goes in cycles. Some of those cycles are colder, with ice spreading far from the poles. We call those the glacial periods. Others are warmer, with ice retreating back toward the poles, like the moment we live in now. Those are the interglacials. Together, glacials and interglacials make up the slow heartbeat of an ice age. And to your great surprise, we are still inside one. Yes, right now, the world you live in is part of an ice age that began roughly 2.5 million years ago, known to scientists as the Quaternary glaciation. We are simply living in one of its warm intervals, an interglacial called the Holocene. The polar ice caps, the great sheet covering Antarctica, the ice that crowns Greenland. These are not leftovers from some long-vanished frozen world. They are the living edges of the ice age we are still inside. To imagine this can be strange. We tend to think of the world as it is, as if the present is the natural and permanent state of things. But the present is just a single frame in a film that has been playing for billions of years. And in the longer view, the cold has been more common than we realize. Through the deep history of the Earth, there have been several major ice ages, separated by long, warm stretches where the poles themselves were free of ice, where forests grew at latitudes that are now buried beneath frozen seas. To get a sense of this, picture the planet as a slow-moving creature. Sometimes it warms, sometimes it cools, sometimes it sweats, sometimes it shivers. The rhythms are driven by forces both internal and external. Volcanoes pour carbon dioxide into the atmosphere over long stretches of time, warming the world. Mountain ranges rise and weather slowly, drawing carbon dioxide back out of the air, cooling it. The sun shifts in its output. The Earth wobbles on its axis. The continents drift across the surface, sometimes blocking ocean currents, sometimes opening them up. And every one of these small, slow changes nudges the climate in one direction or the other. When the conditions align, when the continents sit in just the right places, when carbon dioxide drops below a certain threshold, when the geometry of the Earth's orbit favors cold summers, the ice begins to form. And once it forms, it tends to grow, because ice is white, and white reflects sunlight back into space. And reflected sunlight means less warmth, which means more ice. The cold builds on itself, like a snowball gathering its own momentum. That's the start of an ice age. But there's another thing worth knowing, and this might be the most surprising of all. Across the deep history of the Earth, ice ages are actually unusual. For most of the planet's life, the Earth has been a warm world, often much warmer than it is now. There have been periods when even the polar regions were lush, when crocodile-like reptiles swam in waters that are now frozen seas, when forests stretched into latitudes that today are covered in tundra and permafrost. The default state of the planet, in geological terms, is warm. Ice ages are the exceptions. They are the moments when the world tilts into a colder mode, sometimes for tens of millions of years, before returning to its usual greenhouse rhythm. And yet, even though they are exceptions, the ice ages we have shaped the planet more dramatically than almost anything else. The reason is that ice acts on the world. It is not a passive cover. It moves, it scrapes, it carves, it pushes, it pulls. A glacier kilometers thick is heavy enough to deform the bedrock beneath it. As it slowly flows, it picks up rocks, grinds them against the bedrock, sculpts entire landscapes. When the ice melts, those landscapes remain, and we walk on them today, sometimes without realizing that the hills and valleys around us are the work of ice. So when we speak of ice ages, what we're really talking about is the slow re-engineering of the world by frozen water. They are not just cold spells. They are landscape architects, sea sculptors, ecosystem shifters, and quiet companions to every chapter of life. And to understand what shaped our world, we have to begin by understanding them. We have to begin by knowing what we mean when we say ice age, by understanding that we are still in one, by recognizing that the cold is not always near and not always far, but part of the long breathing of the earth. And once we settle into that view, we can begin to walk back into the deep past, to the very oldest of the ice ages, the ones so ancient and so severe that they almost seem like myths. Long before the dinosaurs, long before the first forests, long before any creature with eyes or bones existed, the Earth experienced ice ages of a kind that we struggle to imagine today. They happened so long ago that the very continents of the time bore no resemblance to ours. The atmosphere itself had a different chemistry. The sun shone slightly less brightly than it does now, and yet, perhaps because of all of these things, the planet was capable of slipping into a cold so deep that some scientists believe ice may have covered nearly the entire globe. We call these the deep freezes, the ancient glaciations, and the most dramatic of them have come to be known by an unforgettable name: Snowball Earth. The idea is almost too vivid to seem real. A planet covered in ice from pole to pole, oceans frozen over so thoroughly that even the equator wore a white crust, continents buried beneath glaciers kilometers thick, a world so cold and so reflective that sunlight bounced off and returned to space, locking the freeze in place for tens of millions of years. The Earth, that warm blue marble we know, transformed into a pale and silent sphere. And the strangest thing is that the evidence for this exists, written into the very rocks beneath our feet. Geologists have found ancient glacial deposits, sediments scratched and shaped by ice, in places that would have been near the equator at the time. The math doesn't quite work unless the ice had spread very far indeed. So we are left with a startling picture: an early Earth that twice, and perhaps more than twice, fell into a frozen state from which it should not have been able to recover. The earliest of these great freezes happened around 2.4 billion years ago in what is called the Huronian glaciation. The world then was very young, and life was just beginning to fill the oceans with the new gas of oxygen, produced by microscopic photosynthesizers. That oxygen, slowly accumulating in the atmosphere, may have stripped away a powerful greenhouse gas called methane, which had been keeping the planet warm. When the methane vanished, the warmth went with it. The Earth cooled, the ice spread, and for hundreds of millions of years, the world was held in a vast and silent winter. Then, far later, around 700 million years ago, the planet did it again. This was the cryogenian period, named for the cold that defined it. Two enormous glaciations occurred during this time, the Sturtian and the Marinoan, and each lasted for tens of millions of years. The continents at the time were arranged in such a way that most of them sat near the equator, with broad, shallow seas at the warmer latitudes. Strangely, this arrangement may have made the planet more vulnerable to freezing. The exposed rock at the equator weathered quickly, drawing carbon dioxide out of the atmosphere. With less carbon dioxide, the climate cooled. Ice began to spread from the poles, and once it reached the warmer latitudes, the runaway effect took over. White ice reflected sunlight, cooled the world further, allowed more ice to form, and so on, until the planet may have been encased entirely. To imagine standing on the surface during one of these freezes is to imagine something almost otherworldly. Picture an Earth where the seas have crusted over with ice meters thick, where wind howls across endless white plains with nothing to break it, where the sun, no longer the warm friend we know, sits in a sky that holds little water, and the air is dry and brittle and cold beyond anything we ever feel in our coldest winters. The temperature at the equator may have been similar to what we now find in Antarctica. The poles may have been colder still, with frost penetrating deep into the bedrock. And yet, somewhere, beneath the ice, in the warm darkness near volcanic vents, or in narrow open belts at the equator, or in small pools warmed by geothermal heat, life persisted. The earliest organisms, simple and tough, held on through that long cold. And when the Earth eventually emerged from these freezes, life emerged with it, often more complex than before, as if the cold had pushed life to evolve. The end of these snowball periods is a story in itself. The freeze should have been self-sustaining. Once everything was white, once sunlight kept bouncing away, the world should have stayed cold forever. But volcanoes never stopped. Beneath the ice, the Earth's internal heat continued to drive its tectonic engines. Lava still poured from cracks, and with the volcanoes came carbon dioxide, slowly added to the atmosphere over millions of years. With life largely held in check by the cold, the carbon dioxide was not being absorbed quickly. It accumulated, and eventually, very slowly, the greenhouse effect built up enough warmth to begin to melt the ice. Once the melting started, it accelerated. Dark water and dark land absorbed sunlight, warmed the air, and the planet emerged from its long sleep. Many scientists believe that just after these great melts, an extraordinary flowering of life followed. The famous Cambrian explosion, when complex animals first appeared in great variety, may owe something to the conditions that emerged after the cryogenian freezes. As if life, having endured such an ordeal, came out on the other side with new possibilities. Other ancient ice ages have left their mark too. The Andean-Saharan Ice Age, around 450 million years ago, glaciated the supercontinent of Gondwana when it sat over the South Pole. The Karoo Ice Age, between 360 and 260 million years ago, brought long, slow glaciations across the southern continents as the great supercontinent of Pangaea was assembling. Each of these left rocks that bear the unmistakable marks of ice, striations, scratches, dropped stones, and tells, like fingerprints on glass. Each of them was driven by combinations of plate tectonics, atmospheric chemistry, and the slow geometry of the Earth in its orbit. Each one shaped life in some way, sometimes by extinction, sometimes by setting the stage for new forms to emerge. And each of them reminds us that the world is not as steady as it seems. The warm seas, the lush forests, the open coasts we love, these are gifts of a particular moment in time. The cold has come before, many times, and in the long view it will come again. But before we move forward into the most recent ice age, the one whose echoes we still hear most clearly, let us pause and remember what came in between. Because between the great freezes, the Earth has often been a remarkably warm and unrecognizable place. If the ice ages were exceptional, then the long stretches between them were the more usual state of the planet. And these in-between times are worth lingering on, because they remind us that the world we see today is not the only version the Earth has ever been. For most of geological history, the planet has been warm, sometimes very warm. Warm enough that polar regions held no ice at all. Warm enough that forests grew at latitudes where we now find tundra. Warm enough that creatures we would associate with the tropics lived comfortably in places we now associate with frost. To imagine these in-between worlds is to imagine an Earth where the very idea of an Arctic or an Antarctic seems strange. After the cryogenian freezes ended, the planet entered a long warm interval. The Cambrian and Ordovician periods, which together cover from around 540 to about 450 million years ago, saw a warm Earth where shallow seas teemed with the first complex animals. Trilobites scurried across the sea floor. Strange relatives of squids and snails left their shells in the mud. Coral-like creatures built reefs, and the climate, for much of this time, was warm and equable. The Andean-Saharan Ice Age, when it arrived near the end of the Ordovician, was severe but brief by geological standards. After it passed, the warmth returned, and the Silurian and Devonian periods brought the first true forests, the first vertebrates that walked on land. By the time we reached the Carboniferous, around 350 million years ago, the world was so lush and so warm that vast tropical swamps stretched across continents, filled with giant ferns, towering tree-like plants, and oxygen levels high enough to support insects of astonishing size. The plant matter that grew in these swamps would, over millions of years, become the coal that powered the Industrial Revolution far in the future. But here, too, ice came eventually. The Karoo Ice Age set in. The southern continents froze. The Permian period that followed saw extremes of climate and ended with the most devastating mass extinction in the history of the planet, a story for another night. After that came the long age of the dinosaurs, the Mesozoic. And here, the warmth was extraordinary. For nearly 200 million years, the Earth's climate held in a deep greenhouse state, sometimes hotter, sometimes cooler, but never with the kind of polar ice we have today. There were no permanent ice caps. The Arctic Ocean was warm enough that crocodile-like reptiles swam in it. Antarctica, when it existed near the South Pole, was covered in forests, not ice. Sea levels were high. Shallow seas drowned the interiors of continents. Carbon dioxide levels were elevated, perhaps 4 to 6 times higher than ours today, and the resulting greenhouse warmth wrapped the planet in mildness. Even after the dinosaurs vanished, the warmth lingered. The early Cenozoic, the era that followed the Great Extinction at the end of the Cretaceous, was still notably warm. During a moment around 56 million years ago, in an event called the Paleocene-Eocene thermal maximum, the Earth heated dramatically. Tropical climates spread north and south. Palm trees grew near the Arctic Circle. Crocodiles swam in waters that today are home to walruses. The seas were so warm that the chemistry of the oceans changed, with cascading effects throughout marine ecosystems. The warmth lasted for tens of millions of years, more or less continuously, before the slow shift toward cool began. And it is this slow shift that brings us, eventually, to the Ice Age we are still inside. But before we go there, let us pause again and feel the strangeness of this longer view. Most of the time, the Earth has been warmer than it is now. Most of the time, there was no ice at the poles. Most of the time, the world wore green and blue, without the brilliant white caps we now see on every globe. To imagine that, you have to set aside the maps you know. You have to picture continents arranged differently, oceans flowing in different patterns, currents bringing tropical warmth to places that now lie under snow. You have to imagine forests in latitudes where we cannot now grow anything taller than a low shrub. You have to imagine swamps and shallow seas, where today there are deserts or icy plains. The Earth has worn many faces, and only a few of them have been frozen. And yet, even in the warm worlds, the slow cooling was already beginning. Through the long, warm middle of the Cenozoic, the climate was gradually drifting downward, almost imperceptibly. The continents were rearranging themselves. Ocean currents were shifting. The great mountain ranges of the Himalayas and the Andes were rising and capturing more and more carbon dioxide through the weathering of fresh rock. The exposed rock of these new mountains, when struck by rain, reacted with the carbon dioxide in the air, pulling it down into the soils and ultimately into the sea, where it was locked away in carbonate minerals. Over millions of years, this slow drawdown of carbon dioxide cooled the atmosphere. Ocean circulation also began to change as the continents settled into roughly their modern arrangement. When Antarctica drifted into its position over the South Pole, a current called the Antarctic Circumpolar Current developed, encircling the continent, isolating it from the warmer waters to the north. With that isolation, Antarctica began to cool. Snow began to gather, glaciers formed, and eventually, by around 34 million years ago, the southern continent was covered in ice. That moment was a turning point. Once Antarctica grew icy, the entire planet began to cool. The northern hemisphere, slower to follow, eventually caught up. Polar ice in the north began to form within the last several million years. The world, in slow motion, was tilting back into a colder mode, and so by about 2.5 million years ago, the planet had crossed a threshold. The cold had returned in earnest. The most recent ice age, the one we are still inside, had begun. And it is this ice age, the Quaternary glaciation, that has shaped our world more directly than any other. It is this one whose echoes we still hear in the rivers and lakes around us, in the soils of our farms, in the very locations of our cities. So let us turn now to that long, slow cooling and step into the world of the Pleistocene, the great age of ice that gave us mammoths, that lowered our seas, that built our landscapes, and that prepared the stage for everything we know. The arrival of the Pleistocene, the epoch we sometimes simply call the Great Ice Age, was not a single moment, but a long descent. For tens of millions of years, the planet had been slowly cooling. Forests had been giving way to grasslands. Polar ice had been building. Glaciers had been reaching downward from the high mountains. By around 2.5 million years ago, the cooling had become severe enough that great ice sheets began to form in the northern hemisphere, on top of land masses that had been ice-free for hundreds of millions of years. North America, Europe, parts of Asia, all of them entered a new kind of climate, a climate that pulsed between cold and colder, a climate dominated by the slow growth and retreat of ice. This is the world we usually have in mind when we say Ice Age, the world of mammoths and mastodons, of saber-toothed cats and short-faced bears, of cave bears and woolly rhinoceroses, the world of the first humans striding out across the land, the world from which our own civilizations would eventually rise. And it is a world whose imprint on the planet is still everywhere, written into the rivers and the lakes and the hills around us. Picture the Pleistocene Earth at one of its colder moments. The continents are arranged much as they are today, but the coasts are different. So much water is locked up in ice that the seas are far lower than they are now, sometimes by more than 100 meters. The British Isles, in those times, were connected to mainland Europe by a broad plain we now call Doggerland, which lies beneath the North Sea. The Bering Strait, between Asia and Alaska, was not a strait at all, but a wide grassland known as Beringia, where mammoths and bison and early humans could walk across what is now ocean. The Mediterranean was lower, the Persian Gulf was a river valley, Indonesia and mainland Asia were joined as one great land. The map you carry in your mind of the world is, in many ways, a snapshot of the brief, warm moment we live in. In the colder times, the world was larger on land, smaller on sea. Now look north. In North America, the Great Laurentide Ice Sheet covers most of Canada and reaches deep into what is now the United States. It is several kilometers thick at its center. It is, in places, twice the height of the Alps. It buries the Great Lakes region, the Hudson Bay, all of New England. It pushes its frozen edge down into Ohio, Illinois, the upper Midwest. In its shadow, the climate of the South is cooler, drier, with vast cold grasslands stretching across what is now temperate forest. In Europe, the Fennoscandian ice sheet covers Scandinavia, much of Britain, the Baltic, parts of northern Germany and Poland. It is no smaller in its own way than its American cousin. Together, these northern ice sheets contain a staggering amount of frozen water, so much that the oceans are noticeably lower and rivers carry much less flow because so much precipitation falls as snow that never melts. And yet, this is only one of the cold phases of the Pleistocene, because something extraordinary happens during this ice age. The cold does not just stay, it pulses. It comes, and then it eases, and then it comes again. Glacial periods of intense cold, lasting perhaps 80,000 to 100,000 years each, alternate with warmer interglacial periods of 10 to 20,000 years. The world breathes in and out of the cold. Through the Pleistocene, scientists count many of these cycles, at least 20 distinct glacial periods, perhaps more, each carving its mark, each leaving evidence in the rocks and sediments. The most recent of them, the one that ended just over 11,000 years ago, is the one we know best. We call it, in the European tradition, the Würm or the Weichselian glaciation. In North America, it is sometimes called the Wisconsinian. It is the one that built the moraines of Long Island, the one that carved the Great Lakes, the one our ancestors walked through as they spread across the continents. But what is striking is that even between these glacial pulses, the Earth never quite returned to the warmth of the deep Cenozoic. The interglacials of the Pleistocene were warmer than the glacials, but they were not tropical paradises. They were more like the world we live in now. Cool poles, ice still present at high latitudes, the Greenland and Antarctic ice sheets still in place. The world breathed cold and colder, with brief sighs of warmth in between. We live in one of those sighs. The Holocene, our present interglacial, is one of the brief warm moments. To imagine the Pleistocene at its coldest is to imagine a world both familiar and strange. The continents are in the right places. The mountains are mostly the ones you know. The rivers run in many of the same directions. But the ice is everywhere in the north. The forests are pushed far to the south. The grasslands sweep across vast cold plains, where today there are forests and farms. The deserts shift. The Sahara, in the heart of the cold, was often drier and more extensive than it is now. In other glacial moments, oddly, the Sahara became green, watered by changes in the monsoon, driven by the very same orbital rhythms that drove the ice. Lakes appeared in basins that today are bone dry. Rivers flowed where today there is sand. The entire planet rearranged itself in response to the cold. The animals adapted. Some grew thick coats of fur and shaggy hides. Mammoths, related to modern elephants, evolved long, curving tusks and dense fur, and walked the cold plains in great herds. Woolly rhinoceroses, with their long, low horns, browsed the cold grasses. Cave bears, larger than any bear alive today, denned in the limestone caves of Europe. Saber-toothed cats stalked the herds of bison and horses across the Americas. Great cave lions, larger than their modern relatives, prowled the cold forests. The world was full of life, but a different kind of life, built for the cold. And through all of this, the world was breathing. The ice would come, and the ice would go, and the world would respond. Each cycle redrew the coastlines. Each cycle reshuffled the species. Each cycle laid down new layers of sediment. Each cycle left new marks on the rocks. We, who live in the warm sigh between the cold breaths, are walking on a planet that remembers. The hills around us, the lakes we love, the rivers we have built our cities along, the very soils of our farmlands, all of it carries the memory of the Pleistocene. But how does the world know when to freeze and when to thaw? Why does the cold come and go so reliably? What sets the rhythm of the ice ages? For the answer to that, we have to look up, away from the earth, into the slow motion of the heavens themselves. To understand why the cold comes and goes, you have to lift your eyes from the ice and look out at the sky. Because the rhythm of the ice ages, the long, slow heartbeat of cold and warmth, is set not only by what happens on Earth, but by the way our planet moves through space. The Earth, as you know, orbits the Sun. It also spins on its own axis, but the orbit is not a perfect circle, and the axis is not perfectly steady. Both of these subtle imperfections drift over time in ways that are slow, regular, and predictable, and together they shape how much sunlight reaches the northern and southern hemispheres at different times of the year. These slow shifts in our planet's geometry are called the Milankovitch cycles, named after the Serbian scientist Milutin Milankovic, who, in the early 20th century, worked out their effects by careful calculation. They are now one of the most beautiful pieces of climate science we have, because they explain something that for a long time seemed mysterious. Why did the ice ages come and go in regular patterns? Why every 100,000 years? Why every 40,000? Why every 20,000? The answer, it turns out, is up in the heavens. Picture the Earth's orbit first. Most of the time, when we draw it in our heads, we imagine a clean circle. But in reality, the orbit is slightly elliptical, slightly stretched. And over time, the degree of that stretch changes. Sometimes the orbit is nearly circular, sometimes it is more elongated. This change happens slowly, over about 100,000 years for one of its main rhythms, and over 400,000 years for another. When the orbit is more elongated, the difference in distance between Earth and Sun at different points in the year is larger. When it is more circular, the distance stays more or less the same throughout the year. This shift in the shape of the orbit is called eccentricity. Next, picture the Earth's axis. It tilts. That tilt is what gives us our seasons. If the Earth were perfectly upright, we would have no summers and no winters, just steady sunlight everywhere all year round. But the tilt is real, and it is currently about 23.5 degrees. That tilt also changes, very slowly, over time. It moves back and forth between roughly 22 and 24.5 degrees, with a cycle of about 41,000 years. When the tilt is greater, the seasons are more extreme, hotter summers, colder winters. When the tilt is less, the seasons are milder. This is called obliquity. And then there is one more wobble, perhaps the strangest of all. The Earth's axis does not just tilt, it also slowly traces a circle in the sky, like a spinning top wobbling at its end. Over about 26,000 years, the axis points to different stars. Right now, it points roughly at the star we call Polaris, the North Star, but it has not always done so, and it will not always do so. The wobble is slow but steady. This is called precession. Each of these three rhythms, eccentricity, obliquity, and precession, affects how much sunlight reaches different parts of the Earth at different times. Together, they create a complicated pattern, but a predictable one. And here is the key insight. To grow ice sheets, you do not necessarily need colder winters. You need cooler summers. Because if the summer is mild enough, the snow that fell during the previous winter does not fully melt. It stays. Year after year, the snow accumulates, compresses, becomes ice. The ice begins to flow, a glacier is born, an ice sheet builds. So when the Milankovitch cycles align in a particular way, when the northern hemisphere experiences cooler summers because the Earth is farther from the sun during its summer months, or because its axial tilt is reduced, or because of the way the wobble shifts the timing of the seasons, the ice begins to grow. And once it grows, the feedbacks kick in. White ice reflects sunlight. The cooling deepens, more ice forms. The world tips into a glacial period. The opposite happens too. When the cycles align toward warmer northern hemisphere summers, the ice begins to melt. Dark land and dark water absorb more sunlight. The warming deepens, more ice melts. The world tips into an interglacial. The pulses we see in the Pleistocene, the 10,000-year warmths and the 100,000-year colds, are written into these orbital rhythms. The whole story is preserved in places we might not expect, in sediments at the bottom of the ocean, in ice cores drilled from Greenland and Antarctica, in the layers of stalagmites in deep caves, in the rings of fossilized corals. Each of these sources holds a record of past climate, and when scientists compare them, they find the same patterns, the same 100,000-year heartbeat, the same 41,000-year tilt, the same 23,000-year wobble. The ice ages, it turns out, dance to the rhythms of the heavens. But there is something deeper here too. The Milankovitch cycles by themselves are not enough. The changes in sunlight they produce are real, but modest. To turn those modest changes into the dramatic swings of an ice age, the Earth itself has to be primed. Carbon dioxide must be low enough in the atmosphere. The continents must be arranged in a way that allows ice to grow on land in the high latitudes. Ocean currents must be configured to transport heat in particular ways. When all of those conditions are met, the orbital rhythms can tip the Earth into glacial cycles. When they are not, the same orbital rhythms produce little more than mild fluctuations. This is why we have not always had ice ages, even though the Milankovitch cycles have always been there. For most of the Earth's history, the planet was too warm for them to matter. It was only when the long cooling of the Cenozoic dropped the world below a certain threshold that the orbital rhythms could finally drive the slow pulsing of cold and warmth that we now call the Pleistocene Ice Age. And so, in a sense, the ice ages are a kind of cosmic music. The Earth's geometry plays the instruments, and the conditions of the planet decide whether or not the music can be heard. When the conditions are right, the music plays loudly, and the world freezes and thaws in slow rhythm. When the conditions are wrong, the music is barely audible, and the planet stays warm. We live in a moment when the music is playing, but we are in one of the quiet pauses. When the ice has retreated, the world is warm, and the next cold beat has not yet arrived. There is something almost poetic about this. The lakes in your country, the rivers that run through your cities, the soils of your farmlands, all of them are partly the work of orbital rhythms, of slow heavenly wobbles that you cannot feel and cannot see. The cold came because Earth, in its slow dance around the sun, tilted its hemispheres in just the right way for ice to grow. The cold went because the dance shifted and the ice was no longer favored. The world is shaped by mathematics we cannot see, by motions we cannot feel, by the patient turning of a planet through space. And tonight, as you rest, that turning continues. The Earth tilts and orbits and wobbles, and somewhere far in the future, in a time we cannot quite reach with our imagination, the music of the ice will come around again, and the world will once more learn the rhythm of the cold. Let us return now to the ice itself, because behind all the cycles, behind all the orbital rhythms and the carbon dioxide changes and the deep cooling of the planet, there is the simple physical presence of the ice. The cold creates it. Snow falls. The snow does not melt, it accumulates, it thickens, it compacts under its own weight. The bottom layers turn from snow into a kind of dense granular ice, and then, under enough pressure, into solid, blue, ancient glacial ice. Slowly, this ice begins to move, not because it wants to, but because it must. The weight of ice on top forces the ice below to flow outward, downhill, toward the edges. A glacier is, in a sense, a slow river of frozen water. A great ice sheet is a vast plateau of frozen water, breathing outward in all directions. At the height of the last glacial period, the ice sheets of the northern hemisphere were so vast that they are hard to picture without standing back. The Laurentide ice sheet, which covered most of Canada and parts of the northern United States, was as large as the modern Antarctic ice sheet. It reached at its center a thickness of perhaps 3 to 4 kilometers. Imagine that for a moment. Imagine a wall of ice taller than most of the mountains you have ever seen, stretching not in a single line, but as a vast white dome covering an entire continent. Imagine it filling the sky from horizon to horizon. Imagine standing at its edge, far in what is now Ohio or Illinois or New England, and looking up at a wall of frozen water that simply does not end. The Fennoscandian ice sheet in northern Europe was almost as great. It covered Norway, Sweden, Finland, the Baltic, parts of northern Germany and Poland, much of Britain, and at its peak it was kilometers thick. Together with the Laurentide and the older Antarctic and Greenland sheets, these vast frozen plateaus held an extraordinary amount of water, enough to lower the sea level around the world by more than 100 meters compared to today. To imagine such a sheet, you have to think about how it moved. Ice, under enough pressure, behaves a little like a very slow, very thick fluid. The interior of the sheet, where it was thickest, accumulated snow year after year. That accumulation pressed downward and outward. At the edges, the ice flowed away from the center, sometimes through narrow corridors called outlet glaciers that streamed downward into the lowlands or into the sea. As the ice flowed, it dragged everything beneath it. Loose rocks, gravel, sand, soil, even fragments of bedrock all became embedded in the bottom of the ice. The ice ground these materials against the rock beneath, scraping and polishing and carving the land. It is impossible to overstate how much work the ice did. Mountains were rounded, valleys were widened and deepened, lake basins were gouged out, river courses were diverted, hills were heaped up where the ice carried debris and dropped it. The geography of most of the northern hemisphere, north of a certain latitude, was completely re-engineered by the ice. Where the ice was thickest and the climate coldest, the ice flowed slowly but with enormous force. Where it was thinner and the climate warmer at its edges, the ice flowed faster, melting and refreezing, sometimes surging dramatically. Massive icebergs broke off where the ice met the sea. Great lakes of meltwater formed at the edges, dammed by the ice itself. These lakes sometimes overflowed in catastrophic floods when the ice dams failed. The landscape of the world today, in the regions that were once under ice, still bears the scars and gifts of these events. There are also more subtle effects. The weight of the ice was so great that it pressed down on the underlying bedrock, depressing the surface of the Earth's crust by hundreds of meters. When the ice melted, the land slowly began to rise again, in a process called isostatic rebound that is still happening today. Scandinavia is still rising. Parts of Canada are still rising. The very ground beneath some cities is, in a sense, still recovering from the weight of ice that vanished more than 10,000 years ago. To stand on the surface of an ice sheet in the depths of the glacial period would have been to stand on a strange world. The air would be cold and dry. The wind would be relentless, blowing outward from the high center of the sheet toward the edges in steady downslope flows we call katabatic winds. The sky, on a clear day, would be brilliantly blue, and the sun, when it appeared, would cast no warmth that you could feel through layers of fur. Snow would drift across the surface like sand in a desert. There would be no plants, no animals, no signs of life, just white and wind, and the slow, almost imperceptible flow of the ice beneath you. At the edges, things were different. There, the ice met the unfrozen land, and a chaotic and dynamic zone unfolded. Meltwater poured from the ice in summer, carving channels through the surrounding sediments. Rocks of all sizes, picked up by the ice from far inland, were dropped at the edge, forming long ridges and mounds we call moraines. Lakes formed where the meltwater pooled. Forests of cold-tolerant trees grew nearby, mostly conifers like spruce and fir and pine. Herds of mammoths, bison, horses, and reindeer moved across the tundra and the cold grasslands. Wolves followed the herds. Foxes and hares and lemmings and a host of smaller creatures filled the ecosystems. And, eventually, humans came. We will speak more of them in time, because their story is woven through the ice. But for now, let us simply rest in the picture of the ice itself. A vast, slow river of frozen water, kilometers thick, sliding silently across continents, sculpting, scraping, carrying, dropping, building landscapes through patience that no human civilization can match. The ice is gone from most of the places it once covered, but its work remains. The very shape of the world owes much of its character to that long, cold patience. The hills you see when you walk in the countryside, the lakes you visit in summer, the fertile plains of grain country, the curve of fjords cutting deep into the coasts, the gentle rises of moraines that look like ordinary ridges, all of these are gifts of the ice, and the ice has not entirely left. There are still ice sheets on Greenland and Antarctica. There are still glaciers in the high mountains, in the Alps and the Andes and the Himalayas and the Rockies. They are smaller than they were. They are receding, but they are still there. They are still working. They are still flowing in their own slow way and carrying with them the memory of the colder world that built them. To stand at the edge of a modern glacier is to stand at the edge of the last fragment of the great ice age that is still ongoing. The ice that flows from those glaciers is, in some cases, hundreds of thousands of years old. Snow that fell in the depths of the last glacial period is still locked inside, slowly making its way to the sea. The ice remembers, and what it remembers, we can read in its layers, like the rings of a tree. Trapped in those layers are bubbles of ancient air, samples of the atmosphere, as it was thousands of years ago. There is dust from distant volcanic eruptions. There are isotopes that tell us the temperature when each layer of snow fell. The ice is a library, written in cold, and we have only just begun to learn its language. So when we speak of the ice ages, we are not speaking only of a chapter in the past. We are speaking of a presence that is still here, in fragments, in echoes, in the very ground beneath our feet. The world we live in is, in many ways, an ice age world, and we should know it, and feel it, and let it humble us, just a little, in the quiet way that great old things can. When the ice was at its greatest, and the world had been reshaped by cold, the work of the ice on the land was already underway. Slowly, patiently, the ice was carving the world, and when, at last, the ice retreated, it left behind a landscape unlike any that had existed before. Many of the features we now consider natural, the rolling hills, the lake-strewn plains, the deep valleys, the curved coasts, the rich soils, the meandering rivers, all of them owe their character, at least in part, to the work of ice. Tonight, let us walk through some of these gifts and learn to read the landscape with new eyes. Consider, first, the Great Lakes. In North America, the Great Lakes themselves, Superior, Michigan, Huron, Erie, and Ontario, are the gifts of the ice. They sit in basins that were gouged out by the Laurentide ice sheet over many glacial cycles. Before the ice came, what is now the Great Lakes region was different. There were rivers, there were hills, there was an older landscape. The ice ground over all of it, deepening valleys, widening basins, carrying away enormous quantities of rock and soil. When the ice retreated for the last time, water filled the basins it had carved, and the largest lake system in the world came into being. The amount of fresh water held in those lakes is staggering, and almost all of it is a gift of the ice. Across the northern parts of North America and Europe, the landscape is dotted with thousands upon thousands of smaller lakes, each one nestled in a depression, scooped out by the ice, or formed where meltwater pooled at the edges. In Finland and parts of Sweden, the land is so covered with lakes that it looks, from above, like lace. The same pattern appears in northern Canada, in parts of Russia, across vast stretches of land that were once buried under ice. Every one of these lakes is a remnant of the Great Cold. Each one is a place where water gathers in a hole the ice carved out, and we, today, sail and swim and rest beside them. Consider also the fjords, those long, narrow inlets of the sea that cut deep into the coasts of Norway, of New Zealand, of Chile, of Alaska, of Greenland. Each of them is a glacial valley flooded by the sea after the ice retreated. Glaciers, flowing down the mountains toward the sea, carved out U-shaped valleys with steep walls and deep floors. When the ice melted and sea level rose, the sea flowed into these valleys, creating some of the most dramatic coastlines in the world. The Norwegian fjords, with their towering walls and dark waters, are perhaps the most famous, but the same kinds of features appear wherever glaciers met the sea. Each fjord is a memory of ice and water, of the slow descent of frozen rivers, and of the rise of the sea that came after. Consider the moraines. These are the great ridges and mounds of rock and soil that the ice carried with it and then dropped at its edges. Where an ice sheet stayed in one place for a long time, its leading edge built up like a slow conveyor belt, piling debris into long ridges that mark exactly where the ice once ended. Long Island in New York is largely a moraine. So are parts of Cape Cod and Martha's Vineyard. Across the upper Midwest of the United States, across Germany and Poland, across vast areas of the Northern Hemisphere, gentle ridges and rises mark the ancient edges of the ice. They are subtle, often hardly noticeable, but once you learn to see them, the landscape begins to come alive with the memory of glaciers. Consider the drumlins. These are oval, elongated hills, shaped a little like upside-down spoons, formed beneath flowing ice. They tend to occur in fields, sometimes hundreds together, all aligned in the direction the ice was moving. They are some of the strangest and most distinctive landforms left by the Great Sheets, and they remain visible in many places today. In parts of Ireland, in New York State, in Wisconsin, in Bavaria, drumlin fields stretch for kilometers, looking like schools of stonefish swimming in the direction of an ice flow that ended 10,000 years ago. Consider the kettles. When the ice retreated, it sometimes left behind enormous blocks of ice buried in the sediments. These blocks slowly melted over years and decades, leaving depressions in the ground that filled with water. Today, these are the kettle lakes, small, round bodies of water, often surrounded by gentle moraine landscapes. They are everywhere across the upper Midwest of the United States and across many parts of Northern Europe, and they are quiet reminders of the time when chunks of ice lay slowly melting, where now there is only stillness and reflection. Consider the rich soils of the Midwest, of Central Europe, of parts of Russia. These fertile plains owe much of their richness to the ice. When the ice ground the bedrock and carried the resulting rock flour southward, depositing it in vast quantities at the edges of the sheets, and when the wind picked up that fine glacial dust and carried it even further, it laid down deep, fine, mineral-rich soils called loess, the breadbaskets of the world, where we now grow much of the wheat and corn that feeds humanity, sit on these glacial soils. The food on your table, if you live in many parts of the world, has roots that go back to the ice. Even the rivers we know have been shaped by the ice. The Mississippi, for instance, carried the meltwater from the Laurentide ice sheet as it retreated, swelling at times to enormous flows. The shape of its valley, the breadth of its lower reaches, the floodplains it built, all owe something to the Great Melt. The Ohio River, the Missouri, the St. Lawrence, all of these carried glacial meltwater. In Europe, the Rhine, the Elbe, the Vistula, all of them were shaped by the ice. The Thames in England runs through a valley remade by the ice. So when you sit beside a river or a lake, you are often sitting beside something that the ice helped create. Even the location of your city might be a gift of the ice. Cities tend to grow where water flows and where the land is fertile, where rivers meet, where there are harbors and lakes and good soils. Many of these features were laid down by the ice or by the meltwater of the ice. Boston, New York, Chicago, Berlin, Stockholm, Helsinki, Moscow, Toronto, all of them sit in landscapes shaped by glaciers. Without the ice, the maps we know would look very different. The hills around these cities, the rivers running through them, the harbors at their edges, all owe at least something to the slow, patient work of frozen water. There is something deeply quieting about thinking of all this. The world feels, in our daily lives, like a stable thing. Mountains seem eternal. Rivers seem unchanging. Lakes seem to have always been there. But on the longer view, all of these features are young. The Great Lakes are only a few tens of thousands of years old in their current form. The moraines of Long Island were laid down within the last 20,000 years. The fjords of Norway were drowned in the rising sea only a few thousand years ago. The soils of the Midwest are still being slowly worked by wind and water and erosion. The world we know is the most recent layer of a much older work in progress. The ice is the sculptor, and we live in the gallery it left behind. To walk in your own town with this knowledge is to walk in a different way. You may pass a small lake at the edge of the city and remember that it was once a kettle, formed by a melting block of ice. You may climb a low hill and realize you are walking on a moraine. You may sit beside a river and feel, beneath the running water, the memory of glacial meltwater roaring through the same valley long ago. The ice has gone, but its work is everywhere. The world it shaped is the world we share. And tonight, as you rest, the world is still gently settling from that ancient sculpting. Soils still drift on the wind. Rivers still carry sediments to the sea. Coasts still slowly rise where the ice once pressed them down. The work continues, quiet and patient, beneath everything we know. If you let your gaze drift now from the land to the sea, you'll find that the ice ages have left their mark there too, in ways perhaps even more dramatic than anything they did on the surface of the continents. Because when so much water is locked up in ice, the seas themselves must give it up. And what the seas gave up during the Great Glacials was extraordinary. To get a feel for this, consider that the modern ice sheets of Antarctica and Greenland contain enough water that if they were all to melt, the global sea level would rise by something on the order of 60 to 70 meters. Imagine that. The coasts would be submerged. Cities like New York, London, Shanghai, Mumbai would all be underwater. Now consider that during the Great Glacials of the Pleistocene, the ice sheets were several times larger than they are today. There were the Laurentide and the Fennoscandian sheets, alongside ice on the Andes, on the Alps, on the Himalayas, on the mountains of Africa, and on Greenland and Antarctica. All of this ice held a vast quantity of water that had once been in the oceans. The result was that during the coldest moments of the last glacial, sea level was more than 100 meters lower than it is today. In some estimates, perhaps as much as 130 meters lower. That is an enormous change. It transformed the coastlines of every continent. It exposed vast areas of land that today lie beneath the sea. It created bridges between regions that today are separated by water. And in so doing, it shaped the patterns of life on Earth, the movements of animals, and eventually, the migrations of our own species. Let us travel to one of those exposed lands. In the far north, between what is now Siberia and Alaska, there lies a stretch of water we call the Bering Strait. Today, it is a narrow channel, sometimes frozen over in winter, sometimes navigable in summer, but during the Great Glacials, it was no strait at all. It was a vast plain, 1,000 kilometers wide from north to south, a green and yellow tundra grassland we now call Beringia. Mammoths grazed there. Bison and horses and reindeer roamed across its broad sweep. Steppe tundra plants covered its surface. Winds blew dust across it, building up lowest soils that may still be preserved beneath the modern seafloor. And, eventually, humans crossed it. Slowly, over generations, small bands of people, descendants of populations from northeastern Asia, moved across Beringia and into what is now Alaska. From there, when the ice opened a corridor southward, they spread into the rest of the Americas. The peopling of the New World, one of the great chapters in human history, was made possible by the cold, because the cold lowered the seas, and the lowered seas made the land bridge. Without Beringia, the Americas would have been settled later, by seagoing peoples crossing in boats. But the great overland migration that brought humans deep into both continents would not have happened in the same way. Now travel across the world, to the area between Britain and Europe. Today, the North Sea separates them, with Britain forming an island. But during the Great Glacials, the North Sea was largely dry land. We call this lost country Doggerland. It was a broad lowland of rivers and marshes, forests and grasslands, full of mammoths and red deer and aurochs, the wild cattle of Europe. Humans lived there. They hunted, they fished, they made tools, they buried their dead. We know this because their tools, their bones, and even some of their structures have been dredged up from the bottom of the modern North Sea by fishing boats. Doggerland was a real and inhabited country, and it is gone now, drowned by the seas that returned when the ice melted. The British Isles, today separate from Europe, were once connected by this lost lowland. The map with Britain as an island, is a recent thing. For most of the time humans have been in Europe, Britain was part of the mainland, and people walked freely between them across what is now sea. Travel further south, to the islands of Indonesia, and to the seas of Southeast Asia. Today, this region is a complex archipelago, thousands of islands scattered across shallow seas. But during the Great Glacials, the seas were so much lower that most of these islands were joined together with mainland Asia, forming a great peninsula we now call Sundaland. It included Borneo, Java, Sumatra, much of the southern Malay Peninsula, all united as one vast lowland. The same happened on the Australian side. Australia, New Guinea, and Tasmania were joined together as a single continent called Sahul. Between Sundaland and Sahul, however, the seas were deep enough that even at the lowest sea levels, they remained as water. Humans, who eventually made it from Sundaland to Sahul, had to cross those seas by boat, perhaps the earliest evidence we have of long-distance ocean travel. The story of how humans first reached Australia, around 50 to 60,000 years ago, is intimately tied to the geography of the Ice Age world. Travel to the Mediterranean. Today, it is a single connected sea, the heart of so much of the history we know. But during the Great Glacials, it was lower, and parts of it were nearly closed off. The Aegean Sea, the Adriatic, the northern margins of the African coast, all of them had different geometries when the cold held the world. Some islands were joined to the mainland. Some basins held salty lakes rather than fully connected sea. The geography of the Mediterranean world that we know, the world that gave us so many ancient civilizations, only emerged after the seas returned to their current heights. Travel to the Caribbean. During the Great Glacials, many of the Bahamas were exposed, forming a vast platform of dry land. Cuba was larger. The shallow seas around the Florida Keys were dry. The eastern coast of the United States stretched far out into what is now the Atlantic. Mammoths and other large animals lived on these exposed shelves, and their bones are sometimes dredged up by trawlers today, far from any modern land. Everywhere you look, the maps you know are different from the maps of the cold time. The continents grew larger, the seas shrank, new bridges formed between distant lands, new islands disappeared into a single continuous shore. And then, when the warmth returned and the ice melted, the seas rose again. The bridges drowned, the islands returned. The maps as we know them were drawn anew. The drowning was not always slow. Sometimes the seas rose dramatically, in great pulses, as enormous lakes of meltwater were released from collapsing ice dams, as ice shelves broke up and freed huge fragments, as the climate shifted into warmer modes. Sea levels rose by tens of meters in a few thousand years, and in some moments perhaps by several meters in a single century. Coastlines moved inward by kilometers. Whole regions where humans had lived, hunted, built, and buried their dead were lost beneath the waves. Some of the great floods of human myth, of which there are many across many cultures, may carry distant memories of those rising seas. We cannot know for sure, but the geological reality is clear. Many of the lands humans once walked are now seafloor. They are not myth, they are simply submerged. And so, when you stand on a modern coast, you are standing on a recent shoreline. The sea you look at has not always been there. Just a few thousand years ago, it was much further away. The world has changed, and the ice ages are part of why. To imagine our world without the rising seas of the recent past is to imagine a different planet. A planet with no British Isles, with no archipelago of Indonesia, with no Bering Strait, with Australia connected to New Guinea, with a Caribbean of broader plains, with Mediterranean lakes instead of seas. And to know that this older geography was real, was inhabited, was the world of countless generations of plants and animals and people, is to feel the slow grandness of geological time pressing gently against you. The world breathes in, the seas pull back, the lands grow. The world breathes out, the seas return, the lands shrink. We live in one of the breaths, in the warm sigh between the great pulls of the ice. And as you rest tonight, the seas around you, the coasts in the distance, the rivers near your home, all of it is the result of a long, slow giving and taking by the ice and the water. We are guests in a landscape made of breath and time. Now turn from the seas to the life that filled the cold world, because the Ice Age, for all its severity, was not an empty world. It was a world full of animals, of plants, of ecosystems adapted to cold and to the long rhythms of glacial and interglacial. And what a world of animals it was. Some of the largest, strangest, most charismatic creatures ever to walk the earth lived during the Ice Ages. The mammoths, the mastodons, the cave bears, the saber-toothed cats, the giant ground sloths, the woolly rhinos, the Irish elk, the cave lions, the dire wolves. Together they formed what scientists sometimes call the Pleistocene megafauna, the great beasts of the cold time. To imagine them is to imagine a world that feels almost mythic, but was very real. Begin with the mammoths. Mammoths were elephants adapted to the cold. They were not all woolly. There were several species across the Pleistocene world. Some lived in warmer climates, while the most famous of them, the woolly mammoth, was a creature of the cold steppes and tundras of Eurasia and North America. The woolly mammoth had thick layers of fat beneath its skin, an undercoat of fine fur, and long, shaggy outer hair that could reach a meter in length. Its ears were small to reduce heat loss. Its trunk had a special tip adapted to picking up grass even through snow. Its tusks curved in long, dramatic spirals, sometimes reaching 3 or 4 meters in length, used for sweeping snow aside, for combat, for display. Mammoths traveled in family groups, much like modern elephants, led by older females. They left footprints across the vast, cold steppes, from Spain to Siberia to Alaska to the upper Midwest of North America. Their bones still surface today, frozen in permafrost, sometimes with skin and hair and even soft tissues preserved. Picture them, a herd of mammoths moving across a cold plain at dusk, the low sun casting their long shadows across the snow-dusted grass, the wind ruffling their long hair, the calves walking close to their mothers, the adults sweeping their tusks across the surface to expose the green beneath. They lived in a world we have almost lost the ability to imagine, and yet their bones tell us they were here, by the millions, for hundreds of thousands of years. The mastodons were related to the elephants, but more distantly than the mammoths. They lived more often in forested environments, especially in the Americas. They were a bit shorter than mammoths, but heavily built, with long bodies, shaggy hair, and tusks that were less curved. They browsed on twigs and leaves rather than grass, and lived for hundreds of thousands of years across what is now the United States and parts of Canada. Their teeth were strikingly different from those of mammoths, with rounded bumps suited to crushing woody vegetation. The woolly rhinoceros prowled the Eurasian steppes. It was a stout, low-slung creature with 2 horns, one long and forward-pointing, the other shorter and behind it. Its body was covered in thick fur. Its head hung low to the ground, swinging side to side as it grazed. It lived from Western Europe to northeastern Asia, and like the mammoth, it disappeared at the end of the last glacial. The Irish elk, despite its name, was neither uniquely Irish nor truly an elk. It was a giant deer that lived across Europe and parts of Asia. Its most striking feature was its antlers, which could span more than 3 meters from tip to tip, the largest antlers of any deer ever to live. Imagine the strength required to grow them each year, the muscle of the neck needed to carry them, the visual spectacle of 2 males clashing in a forest clearing during the rut. The Irish elk persisted into the early Holocene in some parts of Eurasia, before finally vanishing. The giant ground sloths of the Americas were among the strangest of all. Picture an animal the size of an elephant, related to modern sloths, walking slowly across the open country and forests of the New World on its hind legs, using its long front claws to pull down branches and strip them of leaves. The largest of them, Megatherium, could rear up to a height of perhaps 6 meters. They were creatures unlike anything alive today, and they were among the dominant herbivores of the Americas for a long stretch of the Ice Age. Then there were the predators. The saber-toothed cats, of which Smilodon is the most famous, had immense canine teeth that could be more than 15 centimeters long. They were powerfully built, more muscular than modern big cats, with shorter tails and stronger forelimbs. They hunted the great herbivores of the time. Their fossils are abundant in places like the Rancho La Brea tar pits in California, where they became trapped along with their prey. The cave lion, larger than the modern African lion, ranged across Eurasia. The American lion, even larger than the cave lion, lived in the Americas. Dire wolves, heavier and more powerful than modern gray wolves, hunted in packs across North and South America. Short-faced bears, larger than any modern bear, may have been opportunistic hunters or scavengers, and their long legs suggest they could cover ground quickly. The cave bear, found in caves across Europe, was a vegetarian giant, larger than today's brown bears, and lived through many glacial cycles. The cave hyena, related to modern hyenas but a separate species, scavenged and hunted across Eurasia. There were giant beavers, larger than any modern beaver, glyptodonts that looked like armored cars, woolly mammoths that crossed continents, and many smaller species that have left behind only quiet bones. To imagine all of this together is to imagine a planet that was, in some ways, richer in great animals than the planet we live on today. The Pleistocene megafauna was a magnificent assembly. Vast herds of grazing animals across the cold steppes, smaller groups in the colder forests and the warmer valleys, predators of many kinds keeping the herds in motion, scavengers cleaning up after kills. The system was complex, interconnected, and resilient through many glacial cycles. The animals adapted. They moved north and south as the ice grew and shrank. They evolved subtle differences across populations. They thrived through cold and warmth, through glacial and interglacial, across hundreds of thousands of years. And then, most of them disappeared. Most of the great Pleistocene megafauna are gone now. The mammoths, the mastodons, the woolly rhinos, the saber-toothed cats, the giant ground sloths, the cave bears, the cave lions, the dire wolves. Almost all of them vanished at or near the end of the last glacial period, between perhaps 50,000 and 10,000 years ago. The cause of this great extinction is still debated. Climate change played a part. The shift from glacial to interglacial transformed ecosystems rapidly, broke up the cold steppes, brought new plants, fragmented the ranges of the great animals. But climate change alone may not be enough to explain it, because these animals had survived many such shifts before. The other factor, almost certainly involved, is us, humans. Modern humans had spread out of Africa over the last 100,000 years or so. We arrived in Australia around 50 or 60,000 years ago. Many of the largest animals there vanished within thousands of years of our arrival. We arrived in the Americas around 20 to 15,000 years ago, perhaps earlier. Within a few thousand years, most of the great mammals there were gone. In Europe and Asia, where humans had been present much longer alongside the megafauna, extinctions also occurred near the end of the glacial, particularly affecting the species most sensitive to climate change, combined with hunting pressure. The pattern is suggestive. Wherever modern humans arrived, large animals tended to vanish, whether by hunting, by competition, by ecosystem disturbance, or by some combination of these, together with the changing climate. The exact balance is still debated, but what is clear is that the great Pleistocene world, the world of giant beasts and cold plains and vast herds, came to an end as the warmth returned and as we spread across the continents. The world we live in now is, in many ways, an impoverished version of the one that existed only 10 or 20,000 years ago. The continents have lost most of their megafauna. The grasslands no longer support the great herds they once did. The predators no longer hunt the great prey they once hunted. The ecosystems that remain are calmer, smaller, less dramatic. And while there is something we have gained, our own civilizations, our own world, our own quiet evenings, there is also something we have lost. A wilder earth, a richer earth, an earth that no living human has ever seen. And yet, that earth is closer to us than we sometimes think. In the bones we find, in the cave paintings of southern France and northern Spain, where humans painted mammoths and bison and lions on the walls of deep caves 20 or 30,000 years ago, in the dreams that still drift up to us from a time when our ancestors lived among these great animals, knew them, hunted them, drew them, perhaps revered them. The Pleistocene is gone, but it is not far. And tonight, in the quiet, we can sit with it for a moment and remember. Now let us follow the humans themselves, because we too are creatures of the Ice Age. Our species evolved during the long pulses of glacial and interglacial. Our minds, our bodies, our cultures, all of them were shaped by the world of the cold. To understand who we are, we have to understand what we walked through. Modern humans, Homo sapiens, emerged in Africa around 300,000 years ago, give or take. For much of that time, we lived only in Africa, The continent itself shifted with the glacial cycles. The Sahara, which was sometimes a desert and sometimes a green savanna, expanded and contracted with the changing monsoons. Rainforests grew and retreated, lakes filled and dried. Across all of this, small bands of humans moved, hunted, gathered, raised children, buried their dead. They were not the only humans on Earth. In other parts of the world, other species of human existed. The Neanderthals lived across Europe and Western Asia, descended from earlier humans who had left Africa long before us. The Denisovans, known mostly from a single cave in Siberia and from genetic traces in modern populations, lived across parts of Asia. There were others too. Homo erectus persisted in some regions. Smaller human species, like Homo floresiensis on the island of Flores in Indonesia, lived in isolated places. The world was, for much of the Pleistocene, a planet of many kinds of humans. Around 70,000 years ago, perhaps a little earlier or later, our species began to leave Africa in significant numbers. This was not a single migration, but a slow spreading. Small groups moved into the Middle East, into Europe, into Asia. They met other humans there, Neanderthals, Denisovans. They lived alongside them, interbred with them, sometimes competed with them. Many of us today carry small percentages of Neanderthal or Denisovan DNA in our cells, gifts of those long ago encounters. As the climate fluctuated, our ancestors followed the cycles. When the glacial maximum approached, they moved south or sought refuge in protected valleys. When the warmth returned, they expanded back into the high latitudes. They crossed the Bering Land Bridge into the Americas. They crossed into Australia, navigating sea passages even at low tide. They reached islands that had never had humans before. They spread across the planet during the cold time, and they did all of this with stone tools, with skins, with fire, with their own bodies and minds. The technology of the Ice Age was, by our standards, very simple, and yet, by the standards of any other animal, it was extraordinary. Stone blades, knapped from flint or obsidian or chert, wooden spears tipped with stone or bone needles for sewing skins together to make warm clothing, hide tents and shelters, fires for warmth, cooking, light, protection. With these tools, humans survived in environments that would have killed them in days without preparation. To live through a glacial winter in northern Europe or northern Asia required clothing, shelter, food storage, social cooperation, and deep knowledge of the land. Our ancestors learned all of this. They learned to track animals across the snow, to anticipate the migrations of herds, to find shelter in caves and rock shelters, to store dried meat and fish, to chip stones into precise shapes, to control fire, to communicate complex ideas. The Ice Age was not just survived, it was understood, and the understanding lives in us still. Some of the most beautiful evidence of this comes from the cave art of Europe. In caves across southern France, northern Spain, and parts of Central and Eastern Europe, our ancestors painted on the walls. They painted bison, horses, mammoths, lions, deer, rhinos. With extraordinary skill, they captured the muscles, the proportions, the movement of the animals. They sometimes blew pigment around their hands to leave outlines, like silent signatures. They sometimes painted in places far inside caves, in chambers reached only by long crawls through narrow tunnels, by the flickering light of stone lamps burning animal fat. These paintings are tens of thousands of years old. The artists who made them lived during the height of the last glacial. They saw mammoths walking the cold plains. They lived alongside the saber-toothed cats and the cave bears. They knew the world of the cold, and they thought about it. They imagined it, they drew it, and they left their drawings for us to find, 10 or 20 or 30,000 years later, by candlelight or by the glow of modern electric lamps. Imagine that. Imagine being one of those people, crawling through a narrow stone passage, pigments in a small pouch, a lamp in your hand, the cold air of the cave on your skin, reaching a chamber where the walls are smooth and large, lifting the lamp and seeing the wall, and beginning to paint. Imagine knowing that no one might ever see your work, and painting anyway, because the world of the great animals deserves to be remembered, because the deep cave is sacred, because the act of making something true and beautiful is its own kind of survival. The people who painted those walls were us. Their hands made the same shapes ours can make. Their eyes saw the world we still see, only different. And they were carrying with them the knowledge of how to live in the cold. As the Ice Age continued, humans grew more sophisticated. We invented bows and arrows. We developed needles and tailored clothing. We made boats. We domesticated dogs, perhaps from gray wolves that gradually learned to live near human camps, becoming our oldest companion species. We told stories. We sang. We watched the sky. We learned the patterns of the stars. We marked the passing of seasons. We anticipated the migrations of animals. We carried our dead with us, sometimes for great distances, and buried them with ornaments, with red ochre, with care. The minds of the Ice Age people were as full as ours. The cultures of the Ice Age were as deep as ours. We have always been us. And as the cold finally began to lift, as the great glacial began to end, the world became ready for us to do something new, something that had not been possible before. Settle, stay in one place, build, plant, domesticate. The story of agriculture, of cities, of writing, of civilization itself would unfold in the warmth that followed the ice. But none of it would have been possible without the long preparation in the cold. We are children of the Ice Age. We have not entirely left it. The end of the last glacial period was not a simple thawing. It was not a clean and quick warming. It was, in fact, a long, complicated, and sometimes dramatic transition, full of pulses and reversals, of sudden floods and sudden cold snaps. The ice did not melt evenly. The world did not warm steadily. Instead, the end of the cold was a story of stutter and start, of advance and retreat, until eventually, around 11,700 years ago, the world finally settled into the warm interglacial we still live in, the Holocene. Let us walk through this thaw. Around 20,000 years ago, the last glacial period reached its peak. The ice sheets were at their largest. The seas were at their lowest. The cold was at its deepest. And then, slowly, the ice began to recede. The trigger, as we discussed earlier, was the Milankovitch cycles, the slow shift in the Earth's orbital geometry. Cooler northern hemisphere summers began to give way to slightly warmer ones. The ice began to lose more in summer than it gained in winter. Once the trend started, the feedbacks kicked in. Dark land and dark water absorbed more sunlight. Carbon dioxide began to rise as the warming oceans released it. The warming accelerated. From around 20,000 to 15,000 years ago, the ice was retreating. The world was warming. The seas were rising. Life was on the move. Forests were spreading northward into ground that had been frozen tundra. Animals followed the forests. Humans followed the animals. Coastal communities had to move inland as the seas crept up. New rivers opened. New lakes formed at the edges of the receding ice. The world was in flux. And then, around 12,900 years ago, something strange happened. The warming reversed. The cold returned. For about 1,000 years, the northern hemisphere plunged back into a near glacial climate. The ice sheets, which had been retreating, stabilized or even re-advanced in some places. The temperate forests that had been spreading northward retreated. The tundra returned to lower latitudes. Glaciers regrew in the high mountains. This sudden cold snap is called the Younger Dryas, named after a small Arctic flower whose pollen is found in sediments from that time. It lasted around 1,000 years and then ended abruptly, and the cause of it is one of the more puzzling mysteries of the recent past. The most widely accepted explanation involves the disruption of ocean currents. As the great ice sheets melted, vast amounts of fresh water poured into the North Atlantic. Some of this came in steady streams. Some came in catastrophic floods when enormous meltwater lakes burst through ice dams. One of these lakes, called Lake Agassiz, sat in the middle of North America and was, at its largest, bigger than any modern lake on Earth. When its dam of ice gave way, an enormous volume of fresh water rushed out, perhaps through the St. Lawrence River, perhaps through the Mackenzie River into the Arctic and into the North Atlantic. The fresh water disrupted the great ocean circulation that brings warm water north and cold water south. With that circulation weakened, the northern hemisphere cooled rapidly. The younger dryas began. Whatever the precise cause, the effects were dramatic. People living in the northern hemisphere had to adapt to renewed cold. Plants had to retreat once more. Animals had to shift their ranges yet again. The world had thought it was emerging into warmth and was reminded that the cold was not so easily dismissed. And yet, after about 1,000 years, the warmth returned again. The ocean circulation reorganized. The freshwater input slowed. The orbital forcing continued to favor warming. The ice sheets resumed their retreat. The forests began to spread once more. And around 11,700 years ago, the world entered the Holocene. The Holocene has been remarkably stable. By the standards of the Pleistocene, it has been a period of unusual climatic calm. There have been ups and downs. The mid-Holocene, around 6,000 years ago, was warmer in many places than today, with the Sahara green and lush, with abundant lakes and rivers across what is now desert. There have been smaller cold and warm pulses, like the medieval warm period and the Little Ice Age, but these were relatively gentle compared to the wild swings of the Pleistocene. The Holocene has been, in many ways, a gift of stability, a gift of warmth, a gift of opportunity, and in this gift, our civilizations have grown. It is during the Holocene that humans began to settle, to plant crops, to domesticate animals, to build villages. The first farmers appeared in the Fertile Crescent of the Middle East, in the river valleys of China, in the highlands of New Guinea, in the Andes, in Mesoamerica. They began to grow wheat and barley, rice and millet, taro and yams, corn and squash. They began to herd sheep and goats, cattle and pigs. They began to store food, to build permanent homes, to make pottery, to weave cloth. Within a few thousand years, the first cities arose: Jericho, Çatalhöyük, Uruk, Memphis. The first writing appeared, the first wheels, the first metallurgy, the first kingdoms, the first empires, all of it within the Holocene, all of it dependent on the climatic stability that the long, warm interglacial provided. Imagine if the Holocene had been like the Pleistocene, with great climatic swings every few thousand years. Could civilizations have arisen? Could agriculture have spread? Could the long, patient work of building cities and writing texts and inventing technologies have happened? Probably not. The conditions of the Holocene, calm, warm, predictable enough for crops to be grown reliably year after year, were essential, and those conditions were a gift of the Ice Age, of the way the ice retreated and the world settled into its current configuration. The seas filled in, the coasts stabilized, the rivers settled into their modern courses. The soils, enriched by the work of the ice, became the foundations of agriculture. The breadbaskets of the world are, in many cases, the glacial-derived soils of the formerly cold lands. The world we live in is the world the ice prepared, and yet the Holocene is not eternal. By the rhythms we have studied, the orbital cycles, the past patterns of glacial and interglacial, we might expect another glacial period to begin within the next few tens of thousands of years. Some scientists have argued that the natural rhythm of the ice ages would have begun to tilt back toward glaciation within the next 10 or 20,000 years, perhaps less. Although, with the changes humans have made to the carbon dioxide levels of the atmosphere, the timing of that next glacial may be delayed, or its severity may be altered, in ways we cannot fully predict. But the deeper point remains. The cold has not gone forever. It has only retreated, and the patient rhythms of the Earth, which have always brought it back before, will likely bring it back again in some future age. Long after our concerns of the present, long after our cities have grown old, long after our descendants have changed in ways we cannot imagine, the cold will return. It is part of the breathing of the planet. We are guests in this warm pause. and we should be aware of the largeness of the time around us. But for now, we live in the gift. The thaw has happened, the seas have settled, the land has stabilized, the crops grow, the cities stand, the lakes hold water, the rivers run, the forests breathe, and we, the children of the Ice Age, walk under the warmer sun. And so we arrive at our own time, the world we know, the world of cities and farms, of forests and rivers, of coasts and lakes, of mountains and plains. And as we have walked through the Ice Ages tonight, you may have noticed that everywhere we have gone, we have come back to the present. We have not been able to leave it behind. Because the Ice Ages did not just shape the past, they shaped, in the most direct and ongoing ways, the world we live in now. And so let us spend our final part of the journey here, looking at our own world, with the eyes of someone who has just walked through the cold. Begin with the soil under your feet. If you live in much of Northern Europe, in much of the Northern United States, in much of Southern Canada, or in many parts of Central Asia, the soil under your feet is glacial soil. It was either scraped up by the ice and dropped where you now stand, or carried in by the meltwater of retreating glaciers, or laid down by the winds that picked up the rock flour produced by glacial grinding. The very ground that supports the buildings you live in, the parks you walk through, the farms you eat from, was prepared by the ice. The fertility of these soils is not an accident. It is a gift. Look at the rivers. The rivers of the Northern Hemisphere often run in valleys that were either carved or modified by the ice and its meltwater. The Mississippi, the St. Lawrence, the Rhine, the Danube, the Vistula, the Volga, all of them flowed differently before the ice came. The ice carved new channels, dammed old ones, sent meltwater raging in floods that reshaped landscapes. The directions and depths of the rivers we know are, in many cases, results of the ice. Look at the lakes, the Great Lakes of North America, the thousands of lakes of Finland and Sweden and Russia, the lakes of southern Germany and Switzerland, the lakes of the Canadian Shield. All of them were dug by the ice, scraped out by the great sheets, or formed in pockets where chunks of buried ice slowly melted, or pooled in basins where the land was depressed by the weight of glaciers and recovered too slowly to drain. Every lake you have visited in these regions, every reflection of the sky in still water, every fish that swims and every bird that lands is part of a system whose existence depends on the ice. Look at the coastlines, the coasts of New England, the coasts of eastern Canada, the coasts of northern Europe, the coasts of much of the world are coasts shaped by the rise of the sea that followed the melt. The bays you sail in, the harbors that gave rise to your trading cities, the rocky coves you swim near, the river mouths where the land meets the sea, all of them are products of the post-glacial sea level rise. Without the ice and its melt, your maps would be unrecognizable. Look at the cities. We have already noticed that cities tend to grow where water, soil, and shelter come together. Many of the great cities of the Northern Hemisphere sit in landscapes prepared by the ice. New York, on its glacial moraines, at the mouth of a glacial river. Chicago, at the southern tip of a glacial lake. Boston, on a glacial harbor. Stockholm, in the lake and island country of Scandinavian glacial geography. Helsinki, on a coast that is still rising from the weight of vanished ice. Toronto, on the shore of a great lake. Berlin, on glacial outwash plains. Warsaw, on glacial deposits. The list goes on and on and on. Civilization itself, in much of the Northern Hemisphere, sits on the foundation of the Ice Age. Look at the animals. Most of the great megafauna are gone, yes, but the animals we still have are descendants and survivors of the Pleistocene. The deer in your forests, the elk in your mountains, the wolves and foxes in your wilds, the brown bears, the cougars, the lynxes, the wolverines, all of them lived through the cold time alongside the giants now lost. They carry the genes of Ice Age ancestors. The reindeer of the Arctic are still living among the descendants of plants that grew during the cold time. The Arctic foxes still hunt across landscapes that look much as they did at the end of the last glacial. Even the bison of the American plains are descendants of bison that crossed Beringia from Asia during the cold time. Our wildlife is shaped by the ice. Look at the humans themselves. We carry the cold in us. Our species adapted, in part, to Ice Age conditions. The light skin of northern European populations may have evolved in response to the low sunlight of high latitudes during the glacial. The genes that protect against cold, that allow us to digest the diets of cold lands, that protect against certain diseases prevalent in cold environments, are still with us. Even the way we cluster in social groups, the way we cooperate, the way we share food and shelter may carry echoes of the strategies our ancestors used to survive the long winters of the Pleistocene. We are warm-weather animals, living in a Holocene world, but our deeper biology remembers the cold. Look at our memories. The myths of many cultures speak of long winters, of vast cold, of great floods. We cannot always know whether these stories carry direct memories of the Ice Age and the Great Melt, but they may. The story of the deluge appears in many traditions. The story of the lost lands beneath the sea appears in others. There is a real chance that some of these stories carry distant echoes of the actual events of 10 or 12,000 years ago, when the seas rose dramatically, when ice dams broke, when the world transformed in lifetimes that were too short to absorb the change without trauma. Our oldest stories may be Ice Age stories. Look at our science. Our understanding of climate, of ecosystems, of human evolution, of geology, of so much else, was built in large part by studying the Ice Ages. The ice cores from Greenland and Antarctica are some of the most important scientific archives we have. Each layer tells us about a year of climate, of atmospheric chemistry, of dust storms and volcanic eruptions, going back hundreds of thousands of years. From these records we have learned about the cycles of the past, the rhythms of the climate, the sensitivity of the world to small changes in carbon dioxide and orbit and circulation. We owe a great deal of what we understand about the planet to the ice. Look at our future. The Ice Ages remind us that the climate is not a steady thing. It changes. It cycles. It can change quickly when the right conditions align. As we watch the modern climate shift under the influence of our own emissions of carbon dioxide and methane, the lessons of the Ice Age are not abstract. They are direct. They tell us that ice sheets can grow and shrink, that sea levels can rise and fall, that ecosystems can be transformed within centuries, that human civilizations can be challenged by climate change. The deep past holds a mirror to the deep future, and so the Ice Ages, though they may seem to belong to a vanished world, are part of our present and part of our future. They are in our soils, our rivers, our lakes, our cities. They are in our animals and in our bodies. They are in our stories and in our science. They are in the long rhythms of the planet that we cannot stop and cannot escape. We are not separate from them. We are part of their continuation. And tonight, as you settle deeper into whatever comfort surrounds you, perhaps it is worth holding this for a moment. The cold has shaped us. The ice has carved the ground we walk on. The slow rhythms of glacial and interglacial have built the world we know. We are warm and safe in this brief, warm pause between the cold breaths of the planet, and it is, in its way, a quiet kind of grace. The vastness of the Ice Ages, of the millions of years of cold and warmth, of the great sheets and the great melts, surrounds us still, often invisibly. It is in the bones beneath the museums. It is in the stones beneath the gardens. It is in the slow-rising land of Scandinavia and Canada. It is in the Great Lakes that mirror the sky. It is in the seas that cover lands we once walked. It is in the rivers, the soils, the forests, the hills, the harbors, the soft hills and the quiet plains. The ice has gone, and the ice has stayed, and the ice will likely come again. And in the meantime, we live, briefly and gratefully, in the warmth it has lent us. And with that, we will let our journey rest here for now. If you have enjoyed wandering with me through these ancient frozen worlds, you might consider staying for more of these slow explorations, more stories of the deep earth, more journeys through the long, quiet rhythms of the planet. A like or a subscribe helps these kinds of stories find their way to others who might also enjoy them, but only if it feels right. For now, thank you for listening, and may your night carry a little of the patience the ice itself seems to keep. May your sleep be deep and warm, and may your dreams, if you have them, wander quietly across cold plains, beneath wide skies, far from any hurry. Good night.